Next up, we'll be joined by Ihor from Orally, who will be holding a workshop called Harnessing Full Decentralized and Efficient Oracles for Cross-Chain Usage on the ICP blockchain. So I'm calling up Ihor to the stage. He should be up in a second. And Ihor will be also joined by his colleague from Orally, his colleague Lorenzo. Let me bring him up as well.
Hi, thanks for introduction.
Welcome.
Hello everyone. And today we're gonna show you what this on-chain Oracle is, how it's possible with ICP, and example of usage already.
Yeah, feel free to take it away as soon as you are ready.
Yeah, sure. I'm gonna share my screen. Okay, so firstly, I want to explain how it works. It looks a little bit complicated by first time, but we just focus firstly on two main products. It's called Pythia and Sybil oracles. So Sybil Oracle is price fit Oracle, and it works with exchange rate canister and custom pair if user want to add some specific assets that don't host on different CEXs or banks. So we like make optimization around exchange rate canister, um, fetch data from different sources and stories by caching, and also we like to use super efficient approach by gas cost to translate it to different chain. So we just fetch it from some time on demand when only user try to access this data to use on their dexes. So there is a consumer contracts on different chains, and user by before interaction he just will fetch on the front end side from our Sybil canister this data. If it's not inside caching, in fetches from exchange rate canister or different sources, and sign it with CDCA signature, and the signature is as a proof that data comes really from this canister and could be verifiable on target blockchains. So in user just attach those data to transaction when he want to interact with contracts. Contracts could verify with the orally verifier on those chains that data is correct and use it for different logics. So it's much more efficient gas approach because we just fetch it on demand, and we don't need to translate every like 30 minutes or 10 minutes each asset price to each chain. So it's much cheaper. But anyway, when we have another Pythia canister, it's for automation transaction. So people can create different subscription and put address, blockchain, and a method which need to be triggered. And with this trigger, could attach some data feeds from Sybil, randomness, or pure automation just without any data. And with a combination of these two, you can create Oracle whatever you want. Like you can create different chain with different data feeding, put it in automation, and it will be automate your contract through RPC, and you will have a fresh data every time. So yeah, for now, developers or like a DAO in the future will be able to create this kind of subscription, but also we will provide additional contract on all chains EVM compatible first with registry stuff that you will be able to register to those events even from your chain. Yeah, something like that. And yeah, I think that's it for explanation how it works. And let's check out how it works. So when you need to, it's Sybil product. When you need to fetch some data, you just can easily make a HTTP GET request from this URL which you want, and you will get this kind of data. So just write timestamp decimal and signature as a proof of that only Sybil canister signs those data. And it's getting from cache, but for example, let's check, this is old one, and we can just refresh this, for example, ICP asset price. The first time when we really fetch not getting from the cache, it takes some time because it makes a lot of different requests to different sources through exchange rate canister. And after that, also with ECDCA signature of this data. So it takes some time, but after it, from caching works much faster. And also, I forget to mention that when price is fetching, this like take in account different exchanges and other data providers. So, and with custom pairs rate, also we require to put inside at least 3 sources, but it's more sources easier, it's better. Yeah, so we've got a new data and it refresh, and we can just use it whenever we want. So it's recently updated. Okay, and we can verify it in our verification contract. It's we are not right now on Mumbai, and we can put this data as we are on in the contract. We user just attach all this information to transaction. Transaction will be sent to their contract, and they will be able to call our verifier contract to make a proof that data is correct. But right now we can just put it manually, just to check if verifier works correctly. So it will answer true that answer that is correct, and if you change something, it false. And so we are right now sure that exactly our reporter put this data in assign this kind of data. A reporter is our canister Ethereum address. So we can just ask, for example, through candid here. It's our canister of Sybil. And we can check that this is our reporter. Okay, so and let's try also Pythia. It's for automation. We have a simple contract with just feed, random, and counter, the 3 type of automation that we have. And right now it's everything by 0. And let's try to create another subscription to make it work. So firstly, we just need to choose our contract. Make just set price, so and put inside some data which we recently fetched. So every time with this automation trigger a transaction, it will put inside price feed ICP to USD from Sybil. We need to make a sign-in with Ethereum verification that we are owner of this address, and it will create a wallet balance address for exactly each wallet to top up it and make as execution address on this chain. In this case, it's Mumbai. We need to top up it first before subscription. and subscribe. I just create like a ICP timer that will call 10 minutes, fetch from Sybil the price feed, put it and call make a transaction, sign it with our execution wallet, which we recently topped up, and send it through RPC to this address with this method. Sometimes we have a problem with gas calculation. For now, we are researching how to fix it. Yeah, but right now it's created, and we can check it out. It should make a first execution soon, and the next one only in 10 minutes. And you can stop it, you can withdraw, and do whatever you want. It's our contract that we need to update, and I want to open our wallet, execution wallet, from which gonna make some transaction. And while we are checking if it works correctly, we can also check another wallets to see already executed transaction. For example, here we have also Mumbai, but with set price. No, let's check another one. Ongoingly, but this is already. I stopped this subscription, but it just make in each 6 minutes it send the transaction to Mumbai and update data. So it was like last time it was put inside the canister Bitcoin feed. Also, I'm gonna show how randomness works. So it also was updated by some period of time, and so it was updated by some interval of time, just a random number, but you also can put whatever you want, bytes or string or different types of data. And it will provide randomness for your contract. So to check out, maybe our contract already executed. And yes, when we need to go, we've put some data inside this contract, and let's check out what data was put in. So it was our contract, and now it's updated. So we make the whole cycle and subscribe for real-time updates for ICP price on Mumbai chain, and it will keep updates each 10 minutes. It will send new price feed. So yeah, actually that's it for example, and I'm gonna ask my teammate Lorenzo to show some EVM oracles that like consumer examples, how you can use it for raffles, for different type of contracts, how you can use this automation, randomness, price feeds.
Amazing. Before Lorenzo takes over, I think that we can answer a question that came up. Artemis asking, how much is the difference in cycles fee when issuing HTTP outcalls to Binance API versus orally for querying an exchange rate?
If you mean by self fetch from your canister, we make like a wrapper for to fetch from a lot of different sources. So you cannot fetch just from a Binance API and be sure that it's a correct data. You need to have much more sources of truth. No, I mean much more sources to be more trustless. And if your API will fall, you need to have like a minimal at 5 and more to be sure that everything will be smoothly. But if we are talking about cycles, you need to clarify expected amount of bits which you get from this request to optimize cycles consumption.
Cool. Amazing. Thank you very much. I think that Lorenzo can go on now with the second part of the workshop. So feel free to kick it off, Lorenzo.
Yeah, awesome. Pleasure to be here. So just to recap, we have on one side Oracle, just for fetching data, verifying it on chain, and consuming data, amongst which also randomness. And then we have Pythia, which is in charge of automating tasks on any kind of EVM chain. Combining the two also makes it possible to create chain link style oracles where the price feed is completely on chain. We can set up tasks which based on a timer update a price like Ihor was showing in his example. But if you want to try and use orally in your EVM contracts, we have a few examples. For example, we have this price consumer example, which inherits from the orally Sybil consumer contract. So extremely easy, just inherit from the orally Sybil consumer class. And during the setup process, indicate the address of the oracle that you want to use. And this is going to be available in our documentation. And for the scope of this example contract, we have two different functions which enable you to update these three variables in a packed way. This is for use cases where you just need to update the value, but you don't actually need to read from it to be more gas efficient. So you just receive the message and a signature. You can verify using the verify packed function that the message was actually signed by a trusted address coming from orally. If you want, the message can be then unpacked and everything can be updated. If you want to have an unpacked update, you can feed to the function the unpacked data and the signature, verified again with the verify unpacked function, and update the variables as needed. We also have an example of Pythia automation with, let's do like a raffle example. Here we have a inheritance from the Oracle Pythia consumer class this time. Again, during setup, you have to indicate the Pythia registry address, which is going to be different for each chain. So again, it's going to be available in our documentation. We are just creating a raffle contract. So we set up a trio of things like the ticket price, the maximum number of tickets before the raffle begins, and users can freely enter the raffle contract through here. This will just make them pay for the ticket and add them to the array with all of the participants. And this is the function that is going to be called by the Pythia executor. You have to use the only executor modifier, and this will make sure that only trusted parties or only trusted addresses from Orally are able to call this function. We have the required statements just to make sure that the function cannot be called unless all of the tickets have been sold in this raffle. And then we are going, the Pythia executor is going to give us a random number. We can just module it by the number of entrants, and we just send the money to the winner. So this is how easy it is to implement either Oracle consumption or automation in your own EVM contracts on an infrastructure completely running on ICP. So completely decentralized Oracle and automation system. Ihor, do you have anything to say?
Yeah, I've seen a question, like, is a Chainlink competitor? Not really, because we are actually, but we have a totally different approach for price feeds. And
so if you've ever had the pleasure of having a call with the Chainlink team, they have extremely strict requirements on having new feeds listed on their platform. They usually require millions of dollars in daily volume, as well as multiple sources of listings, both on DEXs and CEXs. In a way, yes, we can be a Chainlink competitor in the sense that, yes, we do provide oracles, which are both in a verifier system way, but through Pythia, they can made into Chainlink style oracle, as in you can freely fetch the prices on chain, not feeding through the function arguments. But also we are looking to integrating whichever project needs a custom oracle through us. We are extremely versatile in how we can implement and gather our data sources. And so we are a little bit more flexible in that sense.
Awesome. I guess you'll take a couple more questions now, right, guys? Yeah, Zenyar is asking, after canisters are deployed, is the code obfuscated? Can API keys be placed directly into the code?
Yeah, potentially it can. So you shouldn't place any API keys inside a code. It's really hard to decode the stuff from a node, but potentially it's possible.
Yes, and following up to that, canisters can also call HTTP APIs, right?
Yeah, sure. Yes, we do the same.
Yeah, yes, Senior is following up with the question. So how do you provide API keys or any env vars? Could you clarify the question?
Yeah, environment variables. Yeah, we just we don't have secure environment variables, which could be sensitive. So, but API keys for RPCs, for now, it's like open, and but we're looking for a solution to hide it somehow, or use RPC without any like token.
Amazing. I hope that answers the question. There's no questions right now, but guys, if you have any questions, now is the perfect time to ask. We still have some time before the session is over. So we'll give it a minute, I guess, to see if anybody has anything to ask. In the meantime, guys, once more, I'd like to remind you that although this is the final workshop of this week, next week we are continuing the hackathon with 3 more amazing workshops that I hope you will enjoy. There's no workshop on Monday, but we'll continue on Tuesday, then Wednesday, then finally on Friday. Yeah, and also reminder to join both the Encode Club Discord server. I've pasted the link in the chat, and be sure to join the Internet Community Dev Community Discord. These 2 Discord servers are the main places where both us from Encode Club and the Definity team will be providing support throughout the hackathon and trying to answer any potential questions that you might have. Okay, as there are no questions right now, I'd like to thank Ihor and Lorenzo for coming in and holding this very cool, very informative and impressive workshop. And yeah, see you guys next week.
Yeah, thank you very much.
Thank you.